Okay, Algebra 1, this is part 2 of our partial lesson on 7.2, arithmetic sequences written in an explicit, using an explicit rule. And this is task 4, where they're talking about converting between the two types. You can write, given a recursive rule, you can write an explicit rule. Similarly, given an explicit rule, you can write a recursive rule. So here we have a recursively written sequence right here. G of 1 equals 120, so that's the first term is 120. And the common difference is 18 for n is greater than or equal to 2. Okay, so here we go. Let's answer this question here. A, suppose you want to write an explicit rule for the sequence. What information do you need to write the explicit rule? Choose every answer that applies. Then let's do B. Use the recursive rule to find the values that you need to write the explicit rule. Then complete the statements. So you're going to write the first term of the sequence, and then you're going to write the common difference of the sequence. You're going to note that, and you're going to pick that up from this first part right here. So I should have said this earlier, but please write this down exactly this way because you're going to need it. Okay, so the term you want is given by the previous term plus 18. Okay. And then we'll go to C. What is the explicit rule for this same sequence? Remember, in an explicit rule, you write your first term, and then you multiply the common difference for however many terms you want to find, for whatever term number you want to go to. And last but not least, or here, check your explicit rule by verifying that it gives the same value as the recursive rule for G of 3 and G of 5. And please recall that all this means is that we are going to substitute 3 for X, and then we're going to substitute 5 for X. Okay? So here is Katie says that an explicit rule for the sequence is G of n equals 120 plus 18 times n minus 1. Which statement is true? Katie's rule is correct. Katie's rule has the incorrect common difference, or Katie's rule has the incorrect first term. Okay, this is going to be our last task of this lesson. Remember, we are bottom lining it. Remember, we're just introducing these ideas. So we don't need to go super deep into them. But it's important to understand how to graph a sequence. So just like you can graph any other function, like a line, you can graph a sequence. And this is what it looks like. So here we have a position, okay, or your term number, the number of your term, 1, 2, 3, 4, 5. And then you have, this is what the value of the term is at that input. And we go from 35 to 53, 71, etc. And then here you see the sequence graphed. When n is 1, you have 35. When n is 2, you have 53. When n is 3, you have a little over 70, 71. When x is 4, or n is 4, you've got almost 90. And when n is 5, you've got a little, almost 110, 107. So pay attention to this. Please screenshot it or something, and you're going to use this information to answer a couple of questions. So fill in the blanks to show the sequence represented by the graph. So what are the values for y? What are all the values of the terms of the sequence? And then following on to that is B, fill in the blanks to describe how the fifth term is represented. Okay, so you're going to put your X here, your position, and you're going to put whatever that Y is at your input, which is 5, you're going to put that there. Here we have writing an explicit rule. Okay, so you've got your common difference, you've got your first term, then you have your formula, and you put your values in where they belong. And you've got an explicit rule. And I invite you to answer question C. Okay, so 35 is substituted for f of 1 because it is it the first term? Is it the domain? Or is it the common difference? Answer that. Then, why do we substitute 18 for D? What is 18? Is it the first term? Is it the domain? Or is it the common difference? Okay? So there you go. Okay, so there you go. Algebra 1, thank you very much for taking part in this, and we'll see you guys in the next video.